GeoStudio 2021.3 is now available. This video summarizes the new features and improved functionality of GeoStudio, which includes new SlopeW and SigmaW material models, improvements to SequentW and Build3D, and increased interoperability with other Sequent products. Two new SlopeW material models are available in GeoStudio 2021.3. A hook brown material model has been added to SlopeW to replace the shear normal estimation routine. The hook brown input parameters can be defined directly or estimated from rock parameters and disturbance. A dynamically updated graph can be used to visualize updates to the function as parameters are modified. The compound strength material model provides the ability to assign strength material models to specified ranges of slice base angles. It is particularly useful in modeling jointed rock mass, where the strength model for the intact rock varies considerably from that used for the discontinuities. With this release, a hook brown model can be used to define the intact rock, while a conventional Moore-Coulomb material model could be used for the joints. The SlopeW solver now implements an under-relaxation technique to improve convergence for trial slip surfaces that are subject to concentrated point loads, such as simulating steeply dipping anchors in a tie-back wall. New material models are also available in SigmaW. The new simple anisotropic clay plasticity model, also known as Sand clay, is able to simulate softening response of clays under undrained compression following K-knot consolidation. This model allows for the simulation of both undrained and drained rate-independent behavior of normally consolidated sensitive clays and over-consolidated clays to a satisfactory degree of accuracy. Sand clay is beneficial for analyzing geotechnical structures constructed on soft clays, such as levees, embankments, and dikes. The hardening soil material model is known to produce more realistic displacement patterns for excavation and tunneling problems into over-consolidated soils. This material model captures hardening behavior in which plastic strains develop at the onset of shearing. The model also simulates nonlinear pre-failure stiffness variations that is different for both loading and unloading-reloading conditions. Improvements were made to the SigmaW Nor Sand material model. The initial density can now be defined using either the void ratio or the state parameter, making it possible to easily simulate increasing or constant density with depth. Dependence of the shear modulus on the void ratio can now be defined via a new customizable built-in function. Finally, new result categories have been added to the draw contours and draw graph commands for visualization of the mobilized strength as soils approach their critical state. Add-ins constitutive models have been re-enabled in SigmaW. The add-in interface has been simplified and the functionality has been improved so that state parameters can be saved and persisted through time from one analysis to another, and plastic states can be set within the add-in and painted in the UI to track the evolution of yield and failure zones. The SigmaW Land Climate Interaction Boundary Condition has been updated with an option to allow for evaporation during rainfall events. This option can be used to reduce deep infiltration in arid and semi-arid climates. Changes in vapor density now account for changes in saturated vapor pressure with respect to temperature. allowing for accurate analysis of liquid water and water vapor transfer processes. Sequent ID licensing is now supported for all GeoStudio products. Sequent ID support opens up access to the Sequent cloud-based licensing system, which introduces the use of GeoStudio subscription licenses, as well as access to GeoStudio resources via the My Sequent customer portal. A Sequent ID will also be required to access the new GeoStudio self-paced online learning courses. Interoperability between Build3D and Leapfrog is now available through Sequent's cloud-based collaboration tool, Central. Build3D can directly connect to a Leapfrog geological model via Central in order to import mesh-based topographic or lithology contact surfaces into Build3D to use as a background mesh geometry or for parametric surface fitting. Changes to the Leapfrog geological model surfaces can be reloaded into your Build3D project, which will automatically update your 3D geometry. Build3D has improved parametric surface fitting, providing the ability to efficiently fit surfaces to imported triangle and quad mesh-based surfaces from Central, DXF, DWG, or STL files. Multiple surface meshes can now be imported simultaneously. The parametric surface fitting feature can also be used to create surface geometry from imported point cloud data. Build3D includes a new transformation tool. Mesh and geometry items imported into Build3D may need to be rotated, scaled, or translated to match the model coordinate system and units. A simple new transformation tool provides the ability to swap coordinate axes, for example, such that the positive y-axis points upwards. The tool also allows for the translation from distant datum to a local origin. Transformation settings can be named and reused when importing additional data from the same source location. When exporting surface meshes and step file geometry from Build3D, the inverse of a named transformation can be applied, so the exported Build3D model will be transformed to the original coordinate system. That concludes our review of the new features and improved functionality available in GeoStudio 2021.3. For more information, please contact the GeoStudio sales team at sales@geoslope.com, or you can submit technical questions through our online support portal. Thank you for watching and enjoy using GeoStudio 2021.3.